Hello everyone, once again welcome to Computer Science in Yoruba and English. In this lecture we're going to be considering Chomsky normal form, and at the end of this lecture we should be able to understand Chomsky normal forms. You should be able to define Chomsky normal form formally. You should be able to convert a given grammar to Chomsky normal form. So what do we mean? Let's quickly go into business. A given grammar G such that it does not produce epsilon and it does not produce any units is said to be in Chomsky normal form if it's in one of the following forms: A as a non-terminal variable producing B, C, such that B and C are non-terminal variables. Or it can also be in this format: a non-terminal variable A produces B such that B is a terminal variable. So if you check a grammar and you have any of the rules contradicting these two, so we can say that such grammar is not in Chomsky normal form. And the essence of this lecture is to walk you through the process of converting a grammar from its current form to a Chomsky normal form. So without further ado, I'll quickly talk about the fact that we've already treated epsilon production removal and unit production removal. So if your grammar is having unit production, we're supposed to remove it, get rid of it first. That is the first thing we're supposed to do before even venturing into converting into Chomsky normal form, just as we defined that the grammar is not expected to have an epsilon production and also is not expected to have unit production. So if you don't know how to remove epsilon productions or unit productions, I recommend you check out the video. It's right here on YouTube on the channel. So we have A producing BC, as we said, or A producing just one terminal. So if your grammar is in either of these two formats and it does not contain anything contradicting these two, it can be said to be in Chomsky normal form. So without further ado, let's quickly take an example. So we'll be using the same example we've been using right from when we were treating epsilon production removal and unit production removal. So the original grammar has epsilon productions and unit productions, but in the very first step, when we were treating epsilon production removal, we've managed to remove epsilon productions. So in the second step, when we were treating unit production removal, we've managed to remove all the unit productions. So I'll be using that same example, the output from that same example, I'll be using it here so that we can have a grammar such that it fulfills this criteria first, then we try to remove everything that contradicts the Chomsky normal form. So without further ado, let's quickly go into the business of this day. So we have this grammar G. Okay, let me just quickly give a simple algorithm that will help you understand it better. So let's just say for you to convert a given grammar, a given context-free grammar into Chomsky normal form, so follow these three steps. Let's say introduce new non-terminals. Step 1. Step 2 will be to replace terminals not alone, or let me say that are not alone, So the third step will be to begin your fragmentation. So the whole step of converting your grammar into Chomsky normal form, these three will guide us. So what you're meant to do first is to identify your terminal variables. It could be A, B, C, and so on and so forth. And you are meant to replace those terminals with new non-terminal variables. So at the same time, after you must have identified the terminal variables, you are meant to introduce new non-terminals such as n1, n2, n3, and so on and so forth. So you introduce them for as many terminals that we have. So after you must have done that, and we come here to step 2, and what we are meant to do in step 2 here is to look at the terminal variables everywhere we have them in our productions, such that they are not alone. Please, let's note that, such that they are not alone. So we then replace them with the new non-terminals that we just introduced, so such as n1 and so on. So what we are meant to do after then we begin fragmentation. So once I start solving problems now, you understand what I mean by these three. Don't bother if you don't understand them now. So let's quickly. Okay, so for instance, this grammar G has the following: S producing ASB, SB, AS, then A producing AAS, AS, and A, then B produces SBS, BB, AS, AS, and finally A. So if you look at this grammar, you see that most of the things that we have, or let me say many of them, actually conform with what the Chomsky normal form demands. So for instance, this conforms because it has two non-terminal variables. This also conforms because it has two non-terminal variables, but this does not conform. This does not conform. This does not conform, but this actually conforms, and so on and so forth. So, but basically, like I said, the very first thing is to identify the terminal variables. So in this very example, we have terminal variable A and we have B. And if you look, that is all about the terminal variables we have. So we say we have A, B. So what are we supposed to do here? I said we are meant to introduce new non-terminal variables to produce each of the terminal variables we have in our grammar. So what am I trying to say? So I will introduce, for instance, let me say N, so that I can know that it's non-terminal. N, A is producing A. I'm putting this A so that I can recognize it easily. So I'm introducing another one, NB, to produce B. And that is about everything I want to do for now. So the next step, if you remember, I said that you replace terminals that are not alone. So if you look at this, you see that this terminal is alone. This terminal is alone. So it means that I'm not meant to touch them. But if you look at this terminal, it is not alone. This, they are not alone. This is not alone. So I'll be touching them. So what do I mean by touching them is that I'll be altering them and I'll be replacing them with these new non-terminal variables. So what am I trying to say? Anywhere I find A, I'll replace it with NA. Everywhere I find A, except for the ones that are alone, I'll replace them with NA. Everywhere I find B, except for the ones that are alone, I'll replace them with NB. And for this, I'll replace them with NB, NB, and so on and so forth. So, without further ado, let's go into, let me rewrite this in a way that actually include these new productions. So, we have NA producing A. From what we've seen, we have NB producing B, where NA and NB are non-terminal variables. I'm sure we understand that. So we have S producing AS, B, S, B, A, S. That is fine. We have A producing NA AS. A was A before, so we're having NA again, S, and this is not going to change because it's standing alone. So B is producing S. B was A before, so I'm going to replace it with MB. Then S. Then BB was here before, so I'm going to replace it with NBNB. Then AAS was here before, so I'm going to replace it with NAAS. Then AS was here before, so I'm going to replace it with NAS. And A was standing alone, so I'm going to leave it. So these are new productions. So the next step, like I said, is to now begin fragmentation. So what do I mean by begin fragmentation? What I'm actually looking for is to check my productions such that I have more than 2 characters. Let me put it like that. Any of my productions that can produce more than 2 variables, and definitely we can be sure that we are going to have non-terminals. If we're having 2, with this new operation that we just performed, you'll notice that when we're having 2, we can only have 2 non-terminals together, because this guy would have been a terminal, but now we've replaced it with a non-terminal. All these ones would have been terminals, but we replace them with non-terminals. So our next assignment is to find out anyone that we have more than 2. If we count this is 1, 2, 3. So we are going to have to do some kind of fragmentation on it. So if we look at this is 1, 2, 3. So we have to fragment it. We have this 1, 2, so we don't need to touch it. We have this 1, 2, 3. So we have to do some kind of fragmentation. This is just 2, so we don't have to touch it. This is just 2, we don't have to touch it. This is just 2, we don't have to touch it. And how do we fragment? And I think that is the next item on our list. So let me take you through the process of fragmentation. So for instance, I want to quickly explain fragmentation before we go back to the one we just finished. So we're going to say if you have A, B, C, D, E, we have to fragment it such that we produce new rules, we make new productions, or we introduce new non-terminals. Just as we did initially, we are going to introduce some new set of non-terminals and break this guy such that each of the new productions contains exactly 2, not more than 2. How can we do that? You can see that I can write, let's say for instance, this is initially S producing this guy. So I can introduce another variable called S2 and copy the rest of these guys. What am I trying to say? And copy from here all the way down here, leaving A alone, because I only want to have 2 characters at most. So I'm going to copy everything from here, and I'm going to copy it all the way to S2. So let's quickly look at that. If I copy B, C, D, E to S2, I'll say S2 can produce B, C, D, E. So if you look closely, you see that we've copied everything from here. So it means that I can rewrite this guy as S2. I'm believing that is actually very clear enough. So let me get rid of that. So I can write this guy as S2. So if you look at it now, I've managed to bring S to produce only 2 non-terminals by introducing a new non-terminal called S2. So, but if you look closely, you see that I have a new terminal, a new non-terminal called S2, but it has 4. But remember I said I want to have only 2 characters. So what do? I repeat the same process. I can introduce another one called S3 and copy everything from the second character here and bring it here and replace this guy with S3, just as we did initially. So let's do that. S3 equals to CDE, and then I can get rid of this and replace it with S3. But if you look at S3, you see that I still have 3 non-terminal variables, but I only want 2 to be alone. So I'll repeat this process by saying that by introducing S4 and copying everything from this second character here by saying S4 equals DE and replacing this guy with S4. So let me do that now. So S4. So if you look at it now, we see that we've managed to bring the original one, S equals to A, B, C, D, E. We've managed to break it down to 4 different production. If you look at it carefully, you see that this 4 is still the same thing with this very one. And that is how we do our fragmentation. And once we are done with the fragmentation, I tell you that we are done and we've managed to bring everything to Chomsky normal form. So I just intentionally brought out this fragmentation concept so that you understand when we start doing the fragmentation in the solution that we left behind now. So with the idea of fragmentation that we understand now, it means that these 3 characters have to become 2 by introducing additional non-terminal variables. For as many as we need, we introduce them. So this 2 is okay because it actually conforms with what we are supposed to have in Chomsky. And if we look at this 3, it has to be broken down into 2, and that is what we are going to be doing eventually. So let me introduce, okay, let me rewrite this. Okay, let's say NA produces A, NB produces B, S produces ASB, ASB. Remember, I'm still copying my data, but I have to break this guy into another non-terminal. So I can create another variable called S2 and call this SB because I'm copying everything here into this place. So I'm going to get rid of this and change this to S2. So now I have S2, so I can continue my copying. So A produces NA, AS, but I have to find a way to break this down to contain only 2 non-terminals. So I can introduce A2, then say that NA, I beg your pardon, I have to copy everything from second character here and say that this guy can produce AS, and I'll get rid of this guy and replace it with A2. Then I can continue my copying, NAS, then A. So I still have additional rules. Let me try and manage the space. So I have B producing S, NB, and S. So I have to find a way to break this guy into 2. So I'll copy everything from this second character and bring it into a new variable. So I can call this B2 and say NB S. Then I can replace this guy with B2. Then I can copy the data. NA NAAS. So I need to break this guy down to contain only 2. So I can introduce another one called, since I have B2, I can introduce another one called B3 to produce this guy, AS. And I can erase this and change it to B3. So if you keep doing that, just keep adding that. I'm actually trying to manage the space. So, but if you do that, you eventually have a grammar that looks like this. So once we have applied all those things that we've already learned, this is what our new grammar will look like. And as you can see, all the productions, they now conform with what Chomsky is supposed to be giving us. As you can see, we have set of terminals as a single pair, and we have non-terminals. Can you see them? They're just in 2s. And look at them closely, you'll see that they now conform with the definition of Chomsky normal form. And it's actually very, very simple. You just have to practice, as practice makes perfect. So if you have any questions, additions, subtractions, observations as regards anything we've actually covered so far, kindly use the comment section, or you can send an email, csitudes@gmail.com. See you in the next lecture.